Hello everyone, so today we will talk about KCL, which is very important for circuit analysis, Kirchhoff current law. Before we talk about it, let's first talk about Ohm's law, which is a basic to analyze a circuit. So we all know that Ohm's law is just we have a resistor, current equals to V divided by R. We define the current coming from the left to the right. More specifically, the voltage over here is the voltage where the current flow from minus the voltage the current flow to. Like for this case, if the voltage on the left is V1, the voltage at the right is V2, it will be V1 minus V2 divided by the R. So the voltage across it divided by the resistance is the current. And if we define the current is coming to the left, I2, then we know I2 is actually V2. V2 is where it comes from. V1 is where it flow to. V2 minus V1 divided by R. So that's how Ohm's law works. So for the KCL, KCL is Kirchhoff current law, is basically a node analysis. Like there are several versions of it. For example, you have a node, you have 3 rods, you have three current coming into the node. This one is I1, this is I2, this is I3. Then we know that I1 plus I2 plus I3 will equal to 0. And if we have a node, same node, if we have I1 coming out of node, I2 coming out of node, I3 coming out of node, then we also have like I1 plus I2 plus I3 equal to 0. Same node, 3 branch. If we have I1 coming into the node and I2 and I3 coming out of the node, then we have like I1 will be the current coming into the node will equal to the current coming out of node. I1 equal to I2 plus I3. So these three things are the same thing actually. It's just a different way of showing the current. If you draw a current coming down with a negative value, it's the same as a current coming up with a positive value. Yeah, they are the same thing, positive value. If it's coming down with a 10 amp, it is same as coming up with a negative 10 amp. So that's how these three scenarios are the same actually. Let's see an example of the KCL. Simple example to help you understand. So you have a voltage source, V1. You have a resistor, R1. Then you have two resistor, R2 and R3. And then we come back to the voltage source. In this case, we have this current as I1, this current as I2, this current as I3. So we will know that I1 will equal to I2 plus I3 because like I1 is over here. At this point, it will divide into two things. One is I2 coming down. The other one is I3 coming this way. At this point, I2 and I3 join together, and it will form I1 again to this node. That's how this circuit works. But what is I1 exactly? So in this case, we need to calculate the current of I1 first. So I1 is basically the voltage is coming from, which is V1 over here, minus the voltage over here. If we call this voltage Vx, then it will equal to V1 minus Vx divided by R1. And the current of I2 will equal to Vx, where it's coming from is Vx, and it's coming to is over here, which is same as ground, so it's 0 volt. So Vx minus 0 volt divided by R2. And I3 will be equal to the same thing, which is Vx minus 0 volt divided by R3. And we know that I1 will be equal to I2 plus I3. So we know V1 minus Vx divided by R1 will equal to Vx divided by R2 plus Vx divided by R3. And V1 is known, R1, R2, R3 are known. We only have one unknown, so we can solve it based on this equation. There are several other ways to solve it. Like for example, this is one of the way. Another way is like, let me erase this first. First, we can simplify that. We know that R2 and R3, they are actually in parallel. So the equivalent resistance of these two will be the equivalent of the parallel is a product over sum. So it will be R2 product over sum. R2 times R3 divided by R2 plus R3. So the circuit becomes like this: plus minus V1 R1 R2 R3 divided by R2 plus R3. In this case, we know the current here is I1. So what is I1 exactly? So we know this one is V1, this is Vx. So we can say that the I1 will equal to V1 minus Vx divided by R1. So that's this branch. And another way easier is like we can consider R1 and R2 together. So we don't care about the Vx over here. We know this one is 0 volt because it's grounded. So it's actually also equal to V1 minus 0 volt divided by the resistance between, which is R1 plus of this. So it will be R1 plus R2 R3 divided by R2 plus R3. So these two are the same thing. So just depend on where you branch, how did you analyze it. So yeah, so that's an overview of how the KCL worked. Yeah.